All right. So here we go. This is one of our first economics applications of the derivative here. And rather than doing a physics one, we can actually even do other derivative goes into other sciences and fields of learning. And so this is the economics one. So here it says a company usually sells 300 units per month when the price is about $1. After researching the opinions of their customers, they find that they'll lose about 12 units of sale for every 2-cent price change. And when they increase the price, they lose sales. Okay. That's the law of supply and demand or kind of thing. I guess it is kind of the law of supply and demand, but it's actually the law of price. And so, meaning that, you can sell a lot of stuff if it's cheap, but you can sell less stuff if it's expensive. All right. I mean, it's pretty common, assuming there's also no change in the quality of the product. Okay, so let's check this out here. This is the cost function. So if they're selling it for 1 cent, and by the way, X represents how many units they sell. And that's how much the sales per month. All right. And P is the price per unit, which doesn't show up yet, but C is the cost per unit. Okay. So if you're looking at this, if I sell, 300 units, I would put a 300 in here, meaning that each unit, as this goes up, 300, 1, 2, 3, 4, as X becomes greater and greater, I'm adding in an extra 0.2, meaning every unit is about 20 cents to make. All right. We have a fixed cost of 150 no matter how much we sell. For example, if I sell 0 units, I get 0, 0. My cost is still 150. And over here, this is a negative number. And what it does is as my sales go up, or my production goes up, which, by the way, sales and production should be the same amount. Let me write that down. Sales equals production. For this example, we're assuming we sell and produce the same amount. We don't have like leftover products sitting on the shelf. Okay, so as my production goes up, my cost actually goes down by a small amount, but it's not until I get, it's not until I get high in production where this starts to make any significant difference. Okay, so for example, if my production is 10 squared is 100, and so then I multiply 100 by this here, and so my cost really just ends up getting reduced by $1. Okay, that's if I produce 10. And so it's not until I produce, a significant amount here where this starts to actually make a difference. And that's called the economies of scale, which is an economics principle, meaning that as your production level goes up, you tend to be able to produce those later and later objects for less actual cost per object. Anyway, our goal actually here is to determine the best price to maximize profit. And on the tests, I oftentimes just ask this question here. And in order to solve this question, you actually need to do all of the above things. You need to do A, B, D, and E. Okay, you actually don't need this marginal revenue, but we'll do that anyway. So, I'm going to walk you through the whole process of determining the maximized profit by first determining the price function, the revenue function, the profit function, and then we're going to maximize the profit function. Okay? So let's start with the price function. So the price function works like this. You start with your original price of $1, and you start with your original sales, 300. And then, according to the survey that you took, for every time I increase the price by 2 cents, I lose 12 sales. Okay? And so this is an important thing that you want to be able to set up. Okay? And so now we have to build some sort of relationship between this. For example, if I increase my price once by 2 cents, then I lose one set of 12 sales. If I increase my price 2 times, changes this to a 2, then I lose 2 sets of 12 sales. And then so forth. If I change this to a 3, then I lose 3 sets of 12 sales. But we don't want to put a bunch of numbers in there. What we're going to do is put a variable n, okay? And this n represents the number of times that I change the price by 2 cents, okay? I could put a 1 and a 6 here if I wanted as well, but I'm going to put a 2. Now, our goal now is to figure out the price function, which is p of, whoops, this is a lowercase p of x, which should be 1 plus 0.02 n. But what I'm going to do, instead of writing n, I'm going to write x in terms of n over here. If I write x is equal to, I'm going to write n is equal to x minus 300. So if I take away this 300, and then if I divide by a negative 12, I've got my n value in terms of sales. Now if I take that and I plug it into here, I'm having a pretty awesome little relationship here where I've got price in terms of sales. So now I'm allowed to figure out my price in terms of sales. So I'm going to do a little bit of algebra to sort of clean this up. So P of X is 1 plus 0.02x minus 0.02 times 3,000. Oh, let me just do that. That's, I think, 6. Okay. But this 12, this negative 12, goes over top of, or as the denominator of each of these numbers here. This is a minus sign. Okay. So my price function is 1 plus, let's see, if I move my decimal over twice, basically multiply this each by 100, the numerator and the denominator, I get 2x over 1200. And this is going to be a minus, by the way. So it's going to be a minus 2x over 1200 minus a half. The 6 over 12 is a half. Okay? Oh, it's actually plus a half because these two cancel. Don't forget that this minus here went to here. These two minuses. The one in front of the 1200. So now I'm still getting, I'm going to move over to here. So my price function is 1 plus a half is 3 halves. And I'm going to reduce this to a negative x over 600 plus 3 halves. That is my price function. All right, so check on part A. Now, what this does is it represents, as I change my price, this affects the number of sales that I have, keeping into consideration this whole idea where I lose 12 units for every time I change the price. So next question is we have to figure out our revenue function. So this is, by the way, the answer to part A. Now part B is the revenue function. So revenue is equal to price times sales. So R of X is P of X times x, because x represents sales and P of x represents price. So look at this. This is pretty easy. I'm just going to take R of x, P of x, which is a negative x over 600 plus 3 halves. And I'm going to multiply an x next to it. So my revenue function is this. I'll distribute this in just for cleanliness. Okay, plus 3x over 2. And there, that is my revenue function. All right. Now, part C, we actually don't really need to do in order to maximize profit, but I'll do it anyway, because there could be other questions that ask you for the marginal revenue. And essentially, part C is marginal revenue is just the rate of change of the revenue in terms of sales. So it's actually R prime of x. So if I differentiate this, R prime of x, let me give myself a little bit of extra space here. R prime of x is just going to be equal to a negative 2x over 600 minus 3 halves. Okay? And what does this function do? This one just kind of like velocity. All right, let's go back and think about velocity. Remember when the y-axis was position and the x-axis was time, and then I take the derivative, I could call it the rate of change of position over the rate of change of time. Sorry, with respect to time. But physicists were like, let's give it a special word and let's call it velocity. Okay? So now, economists, I guess, would say, hey, I want to know the rate of change of my revenue as my sales change. Okay? Because it's kind of an interesting thing to know, because I kind of want that value to always be positive. As I keep changing and changing my number of sales, I'd like to increase my revenue until finally, at some point, I notice that I'm decreasing my revenue, and effectively, I want to stop now changing my sales. How do I stop changing my sales? I stop changing the price as well. And so there I've then maximized. I've kind of had this idea where I can keep changing and changing until I maximize my revenue. Okay? Now, maximum revenue is pretty nice, but what's better is maximum profit, because revenue doesn't take into consideration cost. Okay? So let's now move into these two last questions. Determine the profit function and the best price to maximize profit. All right. So going down here, profit, which is a capital P, P of X, is revenue minus cost. All right. It's how much I earn, which is revenue, and how much I cost or spend while doing that. And then the leftover is profit. And the idea is you want this to be high. So to do P of X, that was an R. I want to do P of X. I'm going to do the revenue function, which is not R prime. It's just the revenue function, which would be this one here, right here. Okay, so it's a negative x squared over 600 plus 3x over 2 minus the cost function, which is 1 over 1,000 x squared plus 0.2x plus 150. I believe that's what it was. Yeah, I changed this to a fraction, 1/1000th, and I put the x squared as the numerator, and I kept it negative. Did I keep it negative? I did not keep it negative. Let's put that negative in there. Okay. It's a good thing I checked that. So this is now my profit function. Now, as you can see, I've got some like terms here. Here's a like term, and here are some like terms as well. In fact, I'm going to change this to 2/10 into, what was it, 1/5? 2.2 is 1 over 5, which is actually just x over 5. I'm really liking fractions with these. I don't know why. It seems like easier in a way. I mean, I don't know. If you got a calculator, maybe decimals are nice, but fractions are good too, right? You want to start, remember, training your fraction um, capabilities. Okay. So what I'm going to now do is notice that I've got some like terms. I got to get some common denominators here. Well, first of all, before I get too far, actually, oh, shoot, hang on. Before I go too far here, I would like to distribute my negative sign. Okay, boom, 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 just to make sure that I'm not causing any trouble later on down the road. Okay, and I'm just going to do this with a keen eye and make sure I don't make any mistakes. And so that's minus x over 5 and minus 150. Got it. I think I got it. Okay. Now I'm going to get my common denominators here. This is going to be, I'm going to multiply this by 3 over 3. And I'm going to multiply this by 5 over 5. Okay. Giving me a common denominator of 3,000. So my P of x is going to be a negative 5x squared plus 3x squared over 3,000. And now this one, I'll do this in purple, maybe, just for fun. This one I'm going to multiply by 2 over 2. And this one I'm going to multiply by 5 over 5, giving me a common denominator of 10. Okay, so 10. And this turns out to be 15x minus 2x. Is that right? 15x minus 2x. 15x minus 2x. And then I got a minus 150, 150. Common denominator, got it. So P of x is, this is a negative 2x squared over 3,000 plus 13x over 10 minus 150. Okay. Actually, this 2 over 3,000 I can change to 1 over 1,500. Just divide each of those by 2. Then I don't even need that. So there's my profit function. What's so nice about this function? It tells me the profit based on sales. And now I can keep changing my sales until I want the highest amount of profit. I notice that my profit keeps going up. And then if I change my sales anymore, I notice my profit going down. And then I say, oh, wait, I don't want to change my sales anymore. So what does this remind us of? Marginal profit, right? Like marginal revenue, but now I have to figure out the marginal profit. Marginal profit. Okay, so my marginal profit is P prime of x, which is going to be negative 2x over 1,500 plus 13 over 10 plus 0, minus 0. Here it is. Okay. Now, this is my marginal profit. Now, how do I maximize this? Okay, look, thinking about this thing, this is actually a parabola where x is sales and p of x is profit. And since it's a negative parabola, it's a sort of downward facing parabola like this, okay? And there's some point x in sales right here where I will have a maximum amount of profit. And how do I find that? Well, this is p of x, by the way. I made a mistake. This is p of x. I was referring to p prime, but I meant to refer to p of x. So this function here is the one that I'm graphing. I want to graph that function over here. Sorry, let me go ahead and make a bit of a change. So it's negative 150. And then at some point I'll increase my profit, and then I'll come down like this, and I will have the maximum amount of sales. Okay? And by the way, my profit is negative 150 when I sell 0 items. Sales of 0 is the y-axis, because x equals 0 right here. And that makes sense because my profit will be negative 150. Why? Because remember, my cost was 150. So no matter what happens, it had that fixed cost of 150. Anyway, so the point is here's my graph. Now, what's unique about this point? It has a slope of 0. And the slope is p prime of x of 0. And so if I take my p prime of x and I actually get rid of it and put a 0 here, I should actually find the top of the profit function. Not the marginal profit function, but the profit function. So I'm going to do that. This is amazing. And here we go. Now I'm going to solve for x, which is sales. And so now I'm going to subtract 13 over 10 is equal to a negative 2x over 1,500. Multiply by 1,500 and divide by 2. I could have just done like a 750 as well, but whatever. X is negative 13 times 1,500 over 10 times a negative 2. And I get, I don't know what I get, 975. Okay? So apparently, I should sell 975 items, not 300, which means I should reduce my price quite a bit and increase my sales dramatically in order to maximize the profit.